In that same environment, of course, the Kubernetes operator is continuing to run. And every few seconds, the TimesTen operator will monitor the health of TimesTen running in those pods. It not only asks Kubernetes what the state of those pods are, but it will actually look inside of those pods to see what the state of the TimesTen software running inside of them is. So it can look to see if the pod exists, is TimesTen running, is there a database, is the database loaded into memory, is the database ready for use, is replication between the two databases running, etc. And to do this, we run an additional component called the TimesTen agent inside of each of these TimesTen containers in these TimesTen pods. The agent communicates, or the operator communicates with the agent. The agent tells the operator what the state of TimesTen inside of these pods is. And if the operator wants to take some action in order to fix a problem with TimesTen, then the operator will instruct the agent running in a particular pod to do something on the operator's behalf. And the agents will only communicate with the TimesTen operator. So let's walk through a scenario here, right? So let's imagine, failures happen, and so let's walk through a scenario here. We're going to, in this example, let's imagine that the pod containing the active database fails. And that's a problem, of course, because it's the read-write database. It's the one that all of the applications are using. And if that active database fails, that's kind of an emergency, right? Our applications can't run anymore. So something happens, or the pod running the TimesTen database that is the active fails. Naturally, replication doesn't work anymore at that point. The operator can't communicate with that pod that contained the active database. And so very quickly, the TimesTen operator will notice that problem, will instruct the TimesTen agent running in the standby TimesTen database it will instruct it to that standby database to become the active database, right? Okay, you're in charge now. That then becomes the read-only or the read-write database in which the applications can use. And that will automatically cause the application connections from the database connections from applications to automatically flip over from the original active database, which is no longer running, over to the database that was the standby. And so at this point, everything keeps running, right? Applications can continue to operate. No humans had to be involved, right? Nobody had to even notice that this failure happened. All we know is that one of the databases failed. The operator failed over from that dead database over to what was the standby and is now the active. Applications may have seen a very small window of time, a couple of seconds, where things weren't working, but after that, everything picks up right where it left off. And then, of course, after that, Kubernetes will be working to create a new pod to replace that one that had died. And when it does, the TimesTen operator will configure it. Will configure TimesTen in it. So the TimesTen operator will copy over the active database over into that new pod, configure replication, and set it up as a standby with no data loss. And then when that happens, then of course you're back up and running, and you're just as good as new. The roles of the two pods have reversed, but that doesn't really matter to anybody. And all of this happens automatically without human intervention. As I said earlier, we walked through a very simple example here. Naturally, this can be made significantly more complicated. And in a production environment, of course, there would be additional things that we would need to do. There are a number of pieces of metadata that you can provide to the TimesTen operator to allow you to tailor these databases to your specific needs. You can specify the credentials for admin users that have a lot of permissions in those databases. You can create additional users and schemas, tables, and sequences, etc., in these databases as they're rolled out however you like. You can customize the replication scheme between them. to some extent to give you the flexibility that you need. And of course, you can provide necessary TLS certificates for client server and replication to run so you can make sure that your environment runs in a secure way. There are several ways you can provide that metadata to the TimesTen operator. Kubernetes provides a number of facilities such as config maps and secrets and init containers. And we've designed the TimesTen Kubernetes operator so that it's flexible enough so that you can use any of these methods that you choose in order to provide configuration metadata for your TimesTen databases. And the mechanism is generic enough that it can also work with a number of third-party secret managers that are popular out in the real world. Some of the things that you might want to configure, for example, you can configure the amount of resources that you make available in your Kubernetes cluster to TimesTen, such as the size and type of persistent storage, the number of CPUs, and the amount of memory in your Kubernetes cluster that you want to dedicate for the TimesTen databases, etc. And you can also specify complex rules, just as you can in Kubernetes itself, specifying affinity and anti-affinity and other rules that control where TimesTen runs. So for example, you can make sure that your TimesTen databases, the active and the standby database don't run on the same physical hardware, for example. Or you can make sure that one runs in one data center and the other database runs in a different data center. By using standard Kubernetes facilities, which the TimesTen Kubernetes operator makes available to you, you can exercise a lot of control over your environment. So to conclude, TimesTen supports containerized environments via Kubernetes, right? Kubernetes is a very important computing environment, which is really taking a lot of mind share in the computing community, and which is becoming more and more popular for production deployments and in enterprises around the world. And we're happy to officially support Kubernetes in the TimesTen In-Memory Database product. In addition to just supporting it, we've added the Kubernetes operator to the core TimesTen product, which, as you've seen, makes it very, very easy to deploy, monitor, and manage TimesTen databases in your Kubernetes environment, providing you with a robust and fully supported solution that can provide high availability for you for your TimesTen databases in Kubernetes. Kubernetes, as I said earlier, applications are easy to run in Kubernetes if they're stateless. And simple applications like web servers and other stateless applications that don't store any data, they have to have data someplace to get their data, right? And so naturally you're going to use a database in your Kubernetes environment somewhere. And TimesTen, either by itself or in conjunction with the Oracle database, is an excellent fit for your database needs in your Kubernetes environment. Thank you very much for your time, and I hope this was useful.